Once again, welcome to Cambridge A-Level Physics. Topic tonight is 4.3, density and pressure. Right, let's just summarize for you before we look at the syllabus. Right, pressure, we will be looking at density, pressure in fluids. We'll define density, define pressure in fluid. That's our definition. Weight over area or force, normal force over cross-sectional area. Then we'll derive this equation, P equals to H rho G. Right, that's the formula you need to remember. Or we can use this triangle to help you remember. If you want to find density, just cover density is mass or volume. You want to find mass, the cover up mass is density times volume. Right? Mass is density times volume. And finally, upthrust, F equals to V rho G. Some of the reference book that you may want to use. Right? Main thing to have a partial question to try it out topic by topic so that I can reinforce the formula and know how to use the formula. Right? As far as the syllabus is concerned, define and use density, define and use pressure, derive from the definition of pressure and density the equation for hydrostatic pressure, delta P equals to rho G delta H. Use the equation delta P H rho G delta H. Understand that the upthrust on the object in a fluid is due to difference in hydrostatic pressure. Calculate the upthrust acting on the object in a fluid using the equation, right, which is Archimedes' principle. What is given? You need to know G is 9.81. And then hydrostatic pressure is given. Upthrust, right? Usually by doing partial question, you should be able to memorize the equation. In case you forgot, you can go to the formula, which is given in the exam formula sheet and data and formula sheet. Okay. Of course, in physics, you want to know what is density. Density is a physical property of matter. As each element in the compound has unique density associated with it. Density is defined in a qualitative manner as the measure of the relative heaviness of an object with constant volume. We use the same volume to compare. Rather than ask you which is heavier, 1 kilogram of copper or 1 kilogram of paper. Both will have the same weight. Right? Except density will be different as well. For example, rock is obviously more dense than a crumpled piece of paper of the same size. They may have the same size, but this is lighter, is heavier. So greater density, less density. Right? So we define density as mass per unit volume. Right? Definition have to memorize. Mathematically, mass divided by volume. Symbol, in symbol form, rho, Greek alphabet rho, equals to m over v. Mass is in kilogram, volume is in meter cube. So the unit is kilogram meter minus 3. So the substance and their density. right? Wood, low density, air is very low. You need to know that. The magnitude of density in air, you need to know that. Water, you need to memorize that. 1000 kilogram meter minus 3. Others where they require, they will tell you, right? Liquid and solid is about roughly the same order of magnitude. Air, you can see, density is very low compared to liquid or solid. Unit kilogram meter minus 3, 1 gram cm minus 3 equals 1000 kilogram meter minus 3. The alphabet is a Greek alphabet called rho, pronounced rho. It's a scalar quantity. Memorize that, memorize that. They can ask you. In general, density of liquid is approximately the same as density of solid. This is evidence to show that the separation of particles in solid and liquid are almost the same, right? Except liquid, maybe they are separated a little bit further away. Liquid has a slightly lower density compared to solid, except water, right? Let's see that water compared with wood. Density of gas is 1000 times smaller than that for liquid. You can see for air, right? Nearly 1000 times smaller. You can use this triangle to help you find, if you want to find force, is pressure times area. Cover pressure, you want to find pressure, that is force over area. Right? What's the purpose of the airbag? Right? We have studied earlier, there's a force equals Newton's second law. Right? You want the force depends on the final velocity and the initial velocity and the mass of the object. In a car accident, you cannot control the initial velocity because there's a velocity you are driving. But you can lengthen the time. Right? Purpose of the airbag, right? We have said to increase the time interval of impact. Why is the airbag as large as possible? Right? That comes to pressure already. You want to distribute the force over a bigger area. So the force per unit area, which is the pressure, is smaller on your body. The force is spread over a larger area, or force per unit area is smaller. Right? We do apply all these concept physics. That's why we have a right? Snow skiing. Until about 1860, skiing was primarily used for practical transport purposes in snow-rich area. Why can't you just walk on snow? You will sink down. Right? By using a ski, your weight is spread over a bigger area. That's why you won't sink down. Pressure, define pressure. Pressure is defined as the force acting normally. The term is important. Normally means perpendicular per unit surface area. Right? Normal force divided by surface area. In formula form, P equals to F over A. Right? That's the area, that's the force. Normal means the force must be perpendicular to the area. Normal force is usually the weight of the object. State the unit of pressure. Right? Usually you write the formula. Force is in Newton. Area is meter square. So you can call it Newton meter minus 2, or Newton can be expressed as kilogram meter s minus 2. Right? You need to know how to derive this thing. The unit can be Newton meter minus 2, or in terms of base unit, kilogram meter minus 1 s minus 2, or Pascal. Right? to honor the scientists who work in this area. Scalar quantity. Pressure can be measured in millimeter mercury or meter head of water. Same like you use mercury, you use that way. Right? Head of water is just the height of water level. Normal atmospheric pressure is 76 cm mercury. That's called 1 atmosphere. Or 10 meter head of water. Right? That's approximate value. Or 1.01 10 to the power 5 Pascal. That one you need to remember. What atmospheric pressure is 1 times 10 to the power 5 Pascal. Pressure in fluid. Right? That's the atmosphere above. That's the water. There's a point below the water, height below that. There's a surface there. Pressure at a point in the liquid depends on E equals to H rho G. You can use delta H if you want to. Right? Change in height or change in depth. H. Depth below the surface of liquid H. Density of liquid. Acceleration due to gravity. And atmospheric pressure. Right? You can use AT or you can use H. How you can derive it? Consider a cylinder of liquid of height H, cross-sectional area A, base at the same area. Pressure at the base of the liquid due to pressure at the base of beaker or cylinder in this case due to the liquid alone. Right? Volume is the cross-sectional area times the height. Volume of liquid, mass of liquid, right? From this formula, mass is cross multiply density times volume. Weight, right? Weight because mg. And m, we have got that. Right? V rho g, V is AH times the g. So the pressure equals to the force over area, that force there, divided by the area. So it's H rho g. Right? Pressure due to this column of liquid or this cylinder of liquid is of H rho g. Right? You can use that delta if you want to, delta P, delta H. Right? AT is the atmospheric pressure. Sketch the graph to show how the pressure varies with depth on the surface. Right? Always go back to the formula. Pressure, right, at a depth H is your H rho g plus your atmospheric pressure. We can see that this is constant. This is the y-intercept. That's the intercept there. So it's a straight line graph. Compare equation of straight line. Gradient is rho g. Okay, we measure it from the surface downwards. The pressure changes from the seabed. Right? If it's a measure from here at 0 point there, that will be the maximum pressure. It's the same, it's just that the graph is the opposite way, that's all. Going the other way around, the atmospheric pressure is almost the same because it takes quite a fair bit of height for the pressure to change. Right? Compare with the height of the sea. That's why we show it as horizontal. It's slightly decreasing as well. Right, there's your YouTube. So there's application. We take it at the same level. Right? The liquid has a height H1, density rho 1. This on oil or liquid, second liquid, density rho 2, height H2. So the pressure at this level is the same. Right? At this level is the same. H1 rho 1 G, H2 rho 2 G. Right? We choose the same level. It's just like a scale where one side you put same. We're trying to balance it. There's your liquid column. There's your atmospheric pressure. Okay. There's your oil. There's your atmospheric pressure. There's your atmospheric pressure. There's your water or liquid. Rho 1. Can draw that out now. They have different height. Determine the density of liquid. Okay? Can use the YouTube to determine the density of liquid. Right? Water has density that high H1. Oil has density rho 2, high H2. Pressure is the same at the surface of mercury. There's a mercury. At the same level. Pressure here is equal to pressure there. Right? As I said, it's like a level balance. H rho G is the same for both sides. So for this side is H1 rho 1 G plus atmospheric pressure. Right? H2 is acting on this part there. At this point there is H2 rho 2 G plus atmospheric pressure. So atmospheric pressure can cancel off and put in your value. H1 is 51, 53. Okay? Can change it to meter. There's density of water. There's G. H2 is 71 cm. Change it to meter. Density of oil. There's your G. G and G can cancel off. We can calculate out 750 kilogram meter minus 3. Archimedes, a Greek mathematician and inventor named Archimedes, noticed that when he stepped into his bathtub, the water level rose. He reasoned that the weight of water he displaced was equal to the buoyant force in the water. This is called Archimedes' principle and applies to all fluid. Right? Instead of calling buoyant force, which is American, we usually call it upthrust. Upthrust. Right? Upthrust, American buoyant force. So you have a wooden block floating on the liquid. This is the upthrust. The force pushing outwards by the water or liquid, and that's the weight pulling it down. Upthrust is the upward force of liquid on the object floating in the liquid. It can be floating, it can be in the liquid. Origin of upthrust, let's consider this is the whole volume of liquid. There's your object, a cylinder or object, can be any shape, but we choose cylinder easier, or it can be a cube. Right? The top surface is H1 below the liquid surface. The bottom surface of the cylinder of the object is H2 below. Density of liquid is rho, and height of object is H. Object immersed in the liquid or object in the liquid. Pressure increases with that. That's the important thing to remember. Right? H rho G. As H increases, which is the depth, the pressure increases. When an object is placed in a liquid, or we call immersed, pressure P2, that's below here. Pressure P2 is below here. Pressure P1 is on top here. Below the object is greater than the pressure P1 above the object, right? Because it's greater than. H2 is greater. So pressure below here is greater than the pressure above that. Right? P1 is H1 rho G. P2 is H2 rho G. Okay? P2 is just below here. Upthrust is due to the difference in hydroscopic pressure between the upper and lower surface. Upthrust, right? There's a difference in pressure. Just minus that times our area. Right? That's our definition for pressure. F over A. We just take the A across, that's all. Right? There's your P2. This is your P1. Right? And volume of cylinder is AL. Right? We're just using this formula, that's all, for here. Where we cross multiply. Right? So that P2 is greater than P1. So we call that the excess pressure, delta P. It's H2 minus H1 rho G. Right? H2 minus H1 is your H rho G. So upthrust equals to excess pressure times cross-sectional area of object. Right? Thrust, excess pressure, and cross-sectional area of object. That area. This one is here. And the area there. AH is your volume. So there's your upthrust. It's V rho G is equals to weight of fluid displaced. Right? This volume of fluid or volume of solid, same thing. Because it's in the liquid. Density of liquid, that's the acceleration due to gravity. Right? This is given in your data sheet, in your formula sheet, so you don't need to memorize, but it's faster if you can memorize it. Veggie, remember veggie. Rho is your E. Right? Remember what is that? Volume of object in air, same thing. You can use the same formula. Density of air in air, density is 1,000 times less than that of the object. Upthrust in air is usually neglected when we weigh an object in air. Right? That's why when we study air resistance or motion in air, if air resistance is significant, we neglect upthrust because upthrust is too small. Right? So the weight of object in air equals to weight of object, that's all. Right? Don't need to correct for it. Weight of object equals to weight in air. Volume of liquid displaced, if that is your solid floating. Right? When you fill it up to the top there and then you put a solid there, that volume there will be displaced, that volume of liquid there. For a floating object, the volume of liquid displaced, which is this one, equals to volume of solid below the water or liquid surface. That volume. Volume of solid in liquid, that's your volume. For a floating object, if I push it downwards, and if it's floating, it is balanced. But when I push it downwards, the volume of the liquid displaced increases. volume increases, you push it in, volume increases, so the upthrust will increase. That's why when you try to press a wood into the liquid, right, it will not sink, but it will rise up and float again. When all the solid is in the liquid, the upthrust is constant, independent of the depth. Right? So when all the solid is within there, upthrust doesn't change anymore. Only where it's floating, you push it down, it will start to increase until the whole solid, the whole object or the whole body is inside the liquid. Then the upthrust doesn't change anymore. Motion of object in liquid. Object falling with constant speed. What are the forces acting on it? If we have an object, that's the liquid. Direction of motion is downwards. Right? That's the object, that's the liquid. Weight of the object is downwards. Friction between the object and the liquid, or sometimes we call it a drag, is upwards. It's always opposed to motion. Upthrust is also upwards. Right? It's always outwards. So if moving constant velocity, then it's in equilibrium. W equals to U plus F. So we know W is greater than U, W is greater than F. But whether U or F is greater than each other or which one is greater, we don't know. Right? Unless more information is given. U and F, no way to say which is larger. Right? We need more information. There's a pressure gauge or Bourdon gauge used to measure pressure. It's a robust instrument. The pressure is to be measured. It's placed in a flexible metal tube curve, causing the pointer to move over the scale. The pressure measure is the excess pressure of the pressure source compared to the atmosphere. Right? This is mainly for paper 5, where you are required to devise an experiment, investigate the flow of water. Right? Simple one, you can use a funnel. There's a tap, water there. Right? There's a filter funnel. There's a rubber hose. There's a horizontal pipe. Use the spirit level to check that it's horizontal. There's your thread to guide the water down into the beaker. There's a beaker to collect the water and to measure the volume. Right? So are the parameters: length of this tube, diameter of the tube, right? Internal diameter, height of water. Right? You fill it until the water overflow, then the height is constant. Height of water level above the tube. Volume divided by time is the rate of flow. Right? Can calculate the volume for a certain time. To calculate the volume divided by time. Filter funnel must be overflow with water. That's why you have to have a container below that, right, to catch all the excess water, or do it in the near basin. Example, we can investigate how the flow rate is affected by water pressure. Right? We can change its height by changing the height. Right? This is more sophisticated instrument. This one is made of copper. And the tube is all set up for you. Constant head of pressure apparatus. Right? You can join it to a tube there, this tunnel, so that you can see the level of water. As this one goes down, this one will go down. Then you can measure the height. Right? Independent variable. Usually a formula will be given there. Question 1 in paper 5. So how do you measure the pressure? H rho G. volume flow rate, VT, L and D. You can use this one. You can collect the volume, measure the volume with a measuring cylinder. Right? The volume is collected for a certain time t. You have the time, length, and diameter. Use the same tube throughout the experiment, and then make sure the temperature is constant. Use a thermometer to check that. L and H measure using meter rule because it's large. Diameter using a traveling microscope. Right? You cannot use a internal diameter. You can see only, but you cannot touch it. Right? That's why you have to use a traveling microscope. Measure the volume of water collected in time t by a measuring cylinder. Analysis. Right? Usually they have given you a formula. Go to the aim. Right? Plot a graph of volume VOT against your excess pressure. A straight line graph. These are all constant. If you use the same tube, same length, this is a constant. Verify the relationship. So that is your variable. So that is your gradient. Mop any water that spilled. Right? That's your precaution. Spill on the floor to prevent anyone stepping on it and falling. Right? That one summarize for you what we have studied. Density of air, density of water, pressure of a column or cylinder of liquid. And then from that definition of density, we can get our mass is volume and density. Place it inside here. We get our H rho G. Atmospheric pressure, you need to remember, 1000 kilopascal. Horizontally, the two pressure balance. Only the top has a lower pressure, it has a higher pressure. Upthrust, upward force from liquid, is due to the pressure increases with that. Just draw your own mind map to summarize. And upthrust, remember veggie? This looks like E, but it's density. Density of liquid, acceleration due to gravity. Summarize on a piece of paper, then you can memorize it. Okay, so these are the formulas that we are going to use. Okay, which statement defines density of a substance? Right, have a go. C, correct. What's the density of water and air respectively? Right, it's in kilogram meter minus 3. So correct, C. 1 meter cube of water is mixed with 0.5 cm cube of alcohol. Density of water is 1000 kilogram meter minus 3. And density of alcohol is 800 kilogram meter minus 3. What's the density of the mixture with volume? Right? We just need to calculate the total volume of each and total mass of each. Add them up. Total mass divided by total volume is the density of the mixture. Right? Usually draw a table easier. Volume of water times density of water will give you the mass of water. Then density of alcohol, volume of alcohol times density of alcohol give you the mass 400. So add up the total mass, total volume 2. Right? This is the formula we use, mass is density times volume. So average density is just your total mass over total volume, total mass, total volume. So that's the answer we get, D. A wooden block of mass 3 meter, 0.2 meter, and 0.08 meter has a mass of 37.4 kilogram. Calculate the density. Right? Density is mass over volume. So calculate our volume first. Volume. And density is our mass divided by volume. Make sure the unit is correct. And get kilogram meter minus 3. Okay. Let's go to pressure. Okay, what's the definition for pressure? What's your answer? B. Force per unit cross-sectional area. Right? Normally it should be normal force. For substance of volume V and density rho, the weight is same as upthrust. Right? If not, you can derive it. Mass is volume times density. Weight is mg. Mass is V rho times g. Right? So same formula at upthrust. What's the unit of pressure? Right? Derive it. You cannot memorize it. Okay, using formula H rho g or any formula that you want to use. H rho g. H is in meter. Density, kilogram meter minus 3. G is acceleration, meter s minus 2. So simplify it. Got kilogram. This one is 1, this one is 1. We still got meter minus 1. Then this s minus 2. Answer is C. What's the magnitude of atmospheric pressure? Okay, correct. C. A block weight W rests on the side of area A. The gravitational field strength is G. What's the pressure exerted on the ground due to the block? What's your answer? Pressure is weight over area. W over A. The answer is B, correct. Okay. A U-tube containing water is used as a manometer. Okay, this is a past year question. And one end of the manometer is connected to a low pressure chamber. Yeah, low pressure chamber. Both water level in the manometer change by 20 cm. Right? This one down by 20 cm. This one move out 20 cm. Right? Because it's low pressure, it has to move, have to change. Density of water is 1000. That's the water that you use. How far below the atmospheric pressure is the pressure H in the chamber? Right? There's a chamber here. Pressure at the same horizontal level is the same. We take the same horizontal level. Okay, that horizontal level. The atmospheric pressure and the atmospheric that pressure. That's the gas pressure. That's the atmospheric pressure. Right? So pressure at A is pressure at B. Atmospheric pressure is H rho G plus B. So pressure at A is atmospheric pressure minus Right? We take that across there, minus P equals H rho G, and put in your value. H is 0, right? 20, 20, that's your height. So change the meter is 0.4. Density of water is 1000. G, since we are told you to use 10, you use 10. 4000 Pascal. Answer is B. Diagram shows two liquid labeled P and Q, which do not mix. The liquid are in equilibrium in an open U-tube. What's the ratio of density of P or density of Q? Right? Take the same height, same level here, not here. Right? Same level here, because that is where they separate the liquid. This is mercury. This one is liquid P. This is liquid Q. Right? We use H rho G, pressure at A, because pressure at B, same horizontal level is the same. This is 2x times density, rho P times G equals to your, right? This height is H, X, density of liquid Q times G. G and G can cancel off. Then take the ratio, density of P or density of Q. Take this one down. Right? So we got half. Okay. Try this one. The graph shows how the pressure exerted by a liquid varies with depth below the surface. What is the density of the liquid? Go to the formula that we used is November 203, number 5. Pressure is H rho G. That is the gradient. Compare with your equation of a straight line. So rho G equals the gradient. So here, gradient is 300 divided by 0.4. Right? You can take any point, but easier to read a point that is easy to read. Right? Straight away, you get the answer. Right? Use your calculator to calculate out. And you get 760 kilogram meter minus 3, which is that one there. An object immersed in a liquid in a tank experiences an upthrust, which is not the physical reason for upthrust. Pressure in the liquid increases with depth. Pressure below the object is larger than pressure above the object. Upthrust equals to excess pressure times cross-sectional area. Density of body differs from the that of liquid. So what's your answer? Donkey. Right? Density of body differs from that density of liquid. That one doesn't come in. That one doesn't contribute to the upthrust. Okay. Try some question. Okay, here's our partial question 2002 June. A cylindrical block of wood has a cross-sectional area A and weight W. Is totally immersed in water with the axis vertical. The block experiences pressure P top, PT is the top, and PB at the bottom. Surface and respectively, which of the following expression is equal to the upthrust. Right? There's a block. Roughly draw there, you can see what is happening. That's PT, pressure at the top, pressure at the bottom. So answer is C. Okay? We are using pressure is force over area. Upthrust, cross multiply the sub. Upthrust, you can use P, you can use U, or you can use F. Cross multiply. We are not looking for a resultant force on the cylinder. Remember that. We are looking for upthrust. So the difference in pressure times the area. See, this one will give the resultant force. This gives the excess pressure only. A submarine descends vertically at constant velocity. Three forces act on the submarine: viscous drag, upthrust, and weight. Which relationship between their magnitude is correct? Right? The key is constant velocity, that means it's in equilibrium. Right? Roughly draw. You can draw a submarine if you want to, or just draw an object. Motion is downwards. Right? Descent means moving down vertically. So drag will always oppose motion. Upthrust will always be upwards. Weight is going downwards there. So since it's equilibrium, weight equals to drag plus upthrust. Right? So weight is the largest. Descent means going downwards. Drag or friction oppose motion. Right? So W is greater than D, W is greater than U. That's why answer is your donkey. Okay, I think that's the end of the lesson. Thank you for your time. I think that's the end of the lesson. Thank you for your time.